Hi guys, so we're going to go over change in linear and exponential functions today. This is just for the notes. So our linear function versus our arithmetic sequences. We've already talked a little bit about arithmetic sequences in the last video. So here we're just going to go a little bit deeper in there. So our f of x is equal to, you remember this one, mx plus b. But so that way it looks similar to our arithmetic sequence, we're actually going to move the b over. So we'll have b plus m times x. We can do that because it's just addition, so we can just move it over, no problem. Our initial value would be a naught from our arithmetic sequence, or b from our slope-intercept. These two formulas look really similar, and that's why we wrote it this way. Our constant rate of change would be our d, or our m. When not starting with initial value, we can transform the above equation by using the kth term. Our arithmetic sequence is, and then we're going to go through our point slope form of a linear function and our arithmetic sequence with a known kth term. So we just learned this arithmetic sequence formula with our kth. A of n is equal to a of k plus d times n minus k. We do know our point slope formula. We are used to seeing it in the form of m is equal to y2 minus y1 over x2 minus x1. All we're going to do is reframe this into a y equals, which is what our f of x is. So we'll have f of x is equal to y1 plus m times x2 minus x1. Okay, so the point x1, y1 for the linear function is similar to the term k a of k of an arithmetic sequence. So these two are really similar. Our exponential function versus our geometric sequence. Now we're going to go ahead and compare exponential functions to our geometric sequences. Here, our equation for a exponential function is going to be a times b to the x power. And our geometric sequence was g of n is equal to g naught times r to the n power. So for the most part, we will be using r instead of b. So this right here, for the most part, we'll switch it out with r because r stands for ratio, and it helps when we're reading the problem to correlate it to ratio rather than b. When not starting with the initial value, we can transform the above equations by using the kth term. Our geometric sequence is shifted exponential function would be written out as y1 times r to the power of x2 minus x1. Our geometric sequence with a known kth term is g of n is equal to g of k times r to the power of n minus k. The point x1, y1 for our exponential function is similar to the term k, g of k of a geometric sequence. So these two are very similar. Well, remember that the domain of a sequence won't be the same as the domain as a corresponding function. And what that means is that here our domain are simply and strictly just these points. There's no line going through it, therefore they are individual points. If we were to write our domain for this, we would have to write each individual point. So it would be at 0, 1, 2, 3, 4, 5, and 6. So when we would write our domain, we would list it as these individual points. rather than in a function, like how we have up at this side, we would be able to say negative infinity to positive infinity. So how we're going to say that is the domain of this sequence is discrete points. And the domain of this function to our right is all real numbers from negative infinity to positive infinity. All right, great. Now we can move on to the next page. So linear function and exponential functions can both be expressed analytically in terms of an initial value and constant involved with change. There is a difference between the two though. Linear functions are based on addition, exponential functions are based on multiplication. We're going to recognize how to change the output values. Over equal length input value intervals of the output values of a function change at a constant rate. So we'll go ahead and write that in here. At a constant rate, then the function is linear, adding the slope. Proportionality, then the function is exponential. So in this blank, we'll write proportionality. A function has the following coordinate points. Could the function represent a linear function, exponential function, or neither? Okay, so we're going to take a look at our y points after making sure that our x points are going at a consistent rate. So 2 to 3 is only 1 point away, and 3 to 4 is only 1 point away. So we can use these 3 points. Okay, so the difference between 1 and 4 is adding 3. From 4 to 16, we would have to add 12. So this right here would not be linear. We're going to say no. Now let's see if we can multiply anything in order to get to the next point. So multiplying 1 times what to get us to 4? We would multiply that by 4. Now, what do we multiply 4 by to get 16? That is also 4. So here, we found it, and this is, in fact, exponential. Perfect. Now let's try number 2. Oops. Okay, so from 3 to 7, that is 4 away. From 7 to 10, that's 3 away. So close yet so far. So nope, that does not work for this one. Now let's see multiplication. 3 times what to get us 7? Well, 7 over 3 would give us 7. So 7 times what would get us 10? This one would be 10 over 7. So these are also not the same. So this ends up being neither. Okay. From -1 to 7, we would have to add 8. And from 7 to 15, we would also have to add 8. So yes, this is linear. Oh, I almost forgot. We had to check the x's to make sure that they were in equal intervals away from each other. So from 5 to 6, that was 1, and from 6 to 7, that was also 1. So this was possible. We could have done this. It was still neither. This one from 3 to 5, that's a 2-point difference. But from 5 to 7, that is also a 2-point difference. So that means we could do this. It is valid. This would be linear for sure. Okay, now we can go ahead and move on. If we know a function is linear or exponential for sequences that would be arithmetic or geometric, then you only need two distinct values to come up with an equation rule for the function or sequence. It is known that f of x is a linear function and that it passes through the point 3, 7, and 8, 1. Write an equation for this function. So we need to find our slope. The reason being is if we go back, we'll need to find our slope using this formula, and we can write it out just like this. If it's an arithmetic sequence, it can be written just like this. Okay, here it's told that it's a linear function, so we can go ahead and use that equation that we already know, which is m is equal to y2 minus y1 over x2 minus x1. So we can go ahead and label these. We'll have x1, y1, x2, y2. We'll have 1 minus 7 divided by 8 minus 3, leaving us with negative 6 over 5. Perfect. Now we can go ahead and write this out. So this would be f of x is equal to negative 6 over 5 times x minus, and this is where we have a choice. We could either use 3, 7 or 8, 1. We're going to go ahead and write it both ways, but that is an option. So we're going to go ahead and do 3, 7 first. So we're going to plug in our x, which would be our 3, and then plus our y, which would be our 7. So this right here would be a answer. Now, I'm going to also give you the other answer we could use, or f of x is equal to negative 6 over 5, because our slope is going to stay the same for both of these points, multiplied by x minus, and then we are going to use our 8, 1. So our x in this case would be 8 plus our y, which would be 1. Now, if you were taking the AP test, this would look either similar to one of these two options, or they would have multiplied out the negative 6 over 5 and then combined like terms. And then it wouldn't have mattered which one you would have used because it would be the same answer. Okay, let's do this again with number 5. It is known that f of x is an exponential function. So we are looking for an exponential function here. And that it passes through the points 2, 5, and 4, 12. Write an equation for this function. Okay, so our equation, if we look back at our notes, will be y is equal to ab to the power of x. Another way to write this is y is equal to a times r to the power of x. Because here we need to figure out what our ratio is. What is our ratio? Okay, so we do have our x and we do have our y. So our x is 2, our y is 5, and then we have a jump, and then we have 4, and then we have 12. Well, we need to find our r. We know that if we have 5 and we multiplied it by some r, that would actually get us to point 3 comma whatever our y would be in that instance. But we do know what our next jump would be, which would be 12. So if we multiply again by another r, this would actually equal 12. From here, we would be able to start solving for our missing variable. So we'll have 12, and we'll divide by 5 on both sides, leaving us with 12 over 5 is equal to, if we combine r times r, that'll give us r squared. Now, to remove the r squared, we'll need to take the square root. So I'm going to take the square root on this side, which means I have to take the square root on the other. We would be left with r equals the square root of 12 over 5. Now, usually there would be a plus or minus, but our ratios will not be negative. So we do not write plus or minus in this instance. But now we can rewrite our equation. We have the variables that we needed. So here, I'm going to change my color back. We'll have f of x is equal to negative, sorry, f of x is equal to 5 times the square root of 12 over 5 to the power of, oops, ran out of room. I'm going to go ahead and erase that. To the power of x minus 2. So what I used was this first point that was given to me here, but we could also use the second point that was given to us, the 412. So I'm going to go ahead and write or, and then rewrite this using our second point. F of x is equal to 12 times the square root of 12 over 5 to the power of x minus 4. Either one of these would work as an answer. Okay, so let's go ahead and move up and finish this last bit off. Okay, so to wrap up the notes, the following functions are either linear or exponential. Identify the constant, slope, or ratio that causes the output value to change. Now, y is equal to 4 times 2 to the power of x. Since it's to the power of x, this would be a ratio. So here we'll write ratio. And ratio of what? Well, that would be 2. Now we're going to go ahead and do 7. Y is equal to 5x plus 7. What we're looking at is what has the x attached to it. And in this case, it is 5. Since it's not to the power of, it is not a ratio. So this right here would be slope of 5. The following functions are either linear or exponential. Which is it? And justify your answer. So first, we are going to make sure that they are the same length apart with our x's. So the difference between 3 and 7 is 4. The difference between 7 and 11 is also 4. So we can go ahead and get started. Now the difference from 10 to 6 is subtracting by 4, so negative 4. The difference from 6 to 2 is also a subtraction of 4, or adding negative 4. So we need to justify our answer. So we can't just leave it at this is linear. We now need to say this is linear because for each input, change of 4, f has a constant rate of change of negative 4. So when it asks us to justify, we have to give the because. So linear because for each input change of 4, f has a constant rate of change of negative 4. So what's happening to our x's and also what's happening to our y's. Let's go ahead and check our next one, number 9. The difference between 1 and 3 is going to be 2. The difference between 3 and 5 is also 2. Now, let's go ahead and see if they add together, or what adds to 2 to get us 6. In this case, this would be plus 4. From 6 to 18, this is 12, so this is not linear. Let's go ahead and see about multiplication. So what multiplies 2 to get us 6 times 3, 6 to 18, that is also times 3. Okay, so this is exponential. Now we need to write our because. So exponential because for each input change of 2, f changes proportionally by a ratio of 3. And that right there is the end of the notes. Thank you so much for watching, and I hope you guys learned. Have a great day.